Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Bridging Between Algebra and Calculus series and concerns more complicated functions. This guide discusses how more complicated functions can be made from simpler functions. Particular attention is given to the composition of functions and how a function can be decomposed into simpler functions. Introduction. Over the past 300 years, the development of mathematical thinking has been closely associated with the evolution of the definition of a function. A function is a very important concept in mathematics, especially in calculus. Functions are also important in many subjects in which mathematics plays a crucial role, such as computer science, economics, and so on. If you are not familiar with how functions work and the way they are described, you should read the study guides Functions and Using Functions before continuing with this guide. Often in mathematics, you encounter complicated functions in the form of expressions and equations. Understanding how such functions are made is useful. For example, it may help you transpose a particularly intricate equation, correctly perform a calculation, or to choose the most appropriate rule of differentiation or integration. Many complicated functions are the result of a combination of other simpler functions. The simpler functions usually comprise a basis of 5 basic functions, which are used as the building blocks to create more complicated functions. These simple functions are, specifically, x to the power n, sin x, cos x, e to the x, and the natural logarithm of x. See the fact sheet 5 basic functions for more details. Using arithmetical operations to make new functions. One of the most common ways of making new functions is by taking the simple functions described above and combining them using the arithmetical operations, adding, subtracting, multiplying and dividing. You may undertake a combination of any number of these operations to make a new function. Take the simple functions f of x equals cos x and g of x equals x cubed. You can create new functions by 1. Adding or subtracting them. F of x plus g of x equals cos x plus x cubed. F of x minus g of x equals cos of x minus x cubed. 2. You can multiply them. Take their product. F of x multiplied by g of x equals cos of x multiplied by x cubed, which is better written as x cubed multiplied by cos x. 3. You can make new functions by dividing them or finding their quotient. F of x divided by g of x equals cos x divided by x cubed. Or g of x divided by f of x equals x cubed divided by cos x. Note, the denominator cannot be 0. 4. Or you can multiply by a constant a. A multiplied by f of x equals a cos x. A multiplied by g of x equals a x cubed. Composition of functions. There is another very common way of producing more complicated functions. It is called composition. Functions made in this way are called composite functions. To make a composite function, it is useful to think of the analogy of a function being a machine with an input and an output. See study guide Functions. Composite functions result when a function acts as an input to another function. Take f of x and g of x from the previous example. If g of x is used as the input to f of x, it could be pictured as this. In this diagram, x is the input to the first machine, representing the function g. The output of this machine is g of x, which acts as the input to the second machine, representing the function f. The output of the second machine is f of g of x. as the function f is acting upon g of x. The symbols this, which also represent a function, are said f of g of x. Looking at the machine above, the first function acting on x is g, followed by f, but you read f of g of x left to right. It seems to imply that f happens first. When reading functions, you should be aware of this. The order in which the functions act are from inside out with respect to the brackets, or from right to left if you prefer. Returning to the example, as f of x equals cos x and g of x equals x cubed, you can interpret this procedure, f of g of x, as the original input x being cubed and then the cosine of x cubed being taken, resulting in the composite function f of g of x equals the cosine of x cubed. In f of g of x, there are lots of brackets, which may be confusing, so mathematics uses the symbol this to represent composition of functions. So, f of g of x is written f circle g, and similarly g of f of x is written g circle f. In general, f circle g is not equal to g circle f. You can also picture f circle g as a machine with an input x and an output f of g of x, like this. Input x, machine f circle g, output f of g of x. Example: what is the result of the compositions f circle g and g circle f if f of x equals x plus 2 and g of x equals e to the power x? The function f takes the input and adds 2. For the composition f circle g, e to the x is the input to f. So, represented as a series of machines, x is the input to the machine g, whose output is e to the x. This acts as the input to the machine f, which adds 2 to the input and results in e to the power x plus 2. So, f circle g of x equals e to the power x plus 2. The function g raises e to the power of the input. For the composition g circle f, x plus 2 is the input to g, so, represented as a series of machines, x is the input to the machine f, whose output is x plus 2. This acts as the input to the machine g, which raises e to the power of the input, which gives e to the power x plus 2. So, g circle f of x equals e to the power x plus 2, which is not the same as f circle g of x, which equals e to the power x plus 2. In f circle g of x, x acts as the power of e, and so the 2 is added to e to the x, whereas in g circle f of x, 2 is added to x, and then x plus 2 serves as the power of e. Decomposing a function. You have seen how to create composite functions by using one function as an input to another. Being able to look at a complicated function and decide how it was made is an equally important skill known as decomposition. This can be challenging, as decomposing a function is a skill acquired with experience. A good strategy is to look for the 5 basic functions, highlighted in the introduction, within the composite function and work out how they are combined. If there are brackets in the composite function, you can use them to help you. Using BODMAS to help you assess the order and importance of operations, you can start from the innermost bracket and work outwards to decompose functions. See study guide, What Do I Do First? BODMAS. Example: Decompose the function y equals the natural logarithm of the sine of x squared plus 1. The innermost bracket in this function contains x squared plus 1, a polynomial, which acts as the input to the sine function. The result of this acts as the input to the logarithm function. You can think of the overall process as a sequence of three function machines. The first, f, squares the input and then adds 1, or f of x equals x squared plus 1. The second, g, takes the sine of an input, or g of x equals sine x. And the third, h, takes the logarithm of an input, or h of x equals the log of x. Given that x is your original input, you can visualise the composition as the machines. X acts as the input to f, which results in the output x squared plus 1. This in turn acts as the input to g, which gives the output of sine of x squared plus 1. And this in turn acts as the input to h, which gives an output of the final function, the natural logarithm of the sine of x squared plus 1. So the overall function y equals the natural logarithm of the sine of x squared plus 1 is the composition of the functions f, g and h. So y equals h circle g circle f of x, which equals h of g of f of x, which equals the natural logarithm of the sine of x squared plus 1. Further guidance and information. If you have any further questions about functions or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. Telephone 01603 592 761. Email dos.help@uea.ac.uk or visit our website www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills.